All right, welcome to day 2 of lesson 6.2. We're going to talk about polynomial identities. A polynomial identity is simply a mathematical relationship equating one polynomial quantity to another. So here's one that you are probably already familiar with. Let me grab my pen. Let's look at perfect square. So if I have the quantity x plus y squared, okay, we know that that can be expanded so into another polynomial, which is simply x squared plus 2 times x times y plus y squared. So this is a polynomial identity that we've already been using in Algebra 1 and some in Algebra 2, in which the left polynomial is equal to the right polynomial. Now we can use these polynomial identities, and there's many more, but we're going to use this one in particular to do some really cool math problems for mental math. So no calculators today. So let's say I have the math problem that I want to find the square of 27. Okay, that means I have to multiply 27 times 27 and set that up as a multiplication problem, and it's going to take me several steps. Well, using this polynomial identity, we can actually do it a little bit faster. I can break 27 into two numbers that add to give me 27. Well, right off I'm seeing, well, I see 20 and I see 7. Both of those numbers are easy to do multiplication with. So this is going to be equal to 20 is what we set x equal to. 7 is going to be our y. So we start off by x squared. Well, that's simply 20 squared plus 2 times our x, which we said is 20, times y, which is 7, plus, and now we're at y squared, and y is 7, so that's going to be 7 squared. So let's see if we can continue with this with mental math. All right, 20 squared, that's 20 times 20. That's going to give me 400. Plus 2 times 20, which is 40, times 7. Well, let's do 4 times 7 is 28, so I just have to add a 0 then. So that is 280. Plus 7 squared, which is 49. Now you might be able to do the next step all in one line. I'm going to take a couple lines here, and I'm going to first add the first two terms, 428, to give me 680 plus 49. And then I'm going to go ahead and add those two numbers together, and I get 729. So a little bit faster than having to multiply out 27 times 27. Here's another polynomial identity. It's again a perfect square, only here we're subtracting two numbers, squaring it, is equal to x squared minus 2xy plus y squared. So let's use this polynomial identity to determine what 18 squared would represent, or what that equals. So we have to come up with two numbers, first off, for x and y, which when the two numbers subtracted give me 18. So I'm going to go up a little above 18 and choose 20. That means y has to be 2, because when I subtract these two numbers, 20 minus 2, it has to give me 18, which it does. So let's just substitute in then. We have x squared, well that will be 20 squared, minus 2 times x, which is 20, times y, which is 2, plus y squared, which is 2 squared. Simplifying here, 20 squared is 400, minus 2 times 20 is 40, times 2 is 80, plus 2 squared, which is 4. Adding that together, 400 minus 80 plus 4 gives me 324. So 18 squared is equal to 324. Let's look at one more polynomial identity. This is where the quantity x plus y times the quantity x minus y, that will give us x squared minus y squared. That's the difference of perfect squares. Now we can use this polynomial identity to multiply numbers. So let's say you want to multiply the numbers, let's go with 37 times 43. All right, we have to begin by choosing some x's and y's where the two numbers add to give me 43 here. Subtract to give me 37. So that 43 kind of gives me an idea. What if I let x equal 40? Then y equals 3, right? Because when we add these together, we have to get 43. If we subtract them, we do get 47. So that works. So let's go ahead and substitute in then. So 37 times 43 is equal to x squared, so that's just 40 squared, minus 3 squared, which is our y squared. All right, 40 times 40. 4 times 4 is 16. I need to add 2 zeros, minus 3 squared, which is 9, which will equal 1591. And we have multiplied 37 times 43. I hope you've enjoyed learning about polynomial identities. There are many more polynomial identities, and we'll continue to look at these this week and next week. Some of the exponents will change, become a little bit higher degree to the third power. We'll use them here for some mental math as well as when we get into factoring polynomials.